Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad bin Muhammad Zahid. Today I would like to present to you about my final year project proposal, which is the investigation of austenity stainless steel mechanical properties induced by wire art additive manufacturing, which is we call WAAM. So the WAAM technology in our industry is very new. So a lot of us does not know the benefit of WAAM technologies in our industry. So in my investigation, I would like to investigate the mechanical properties in the WAAM sample. For the introduction of wire art additive manufacturing, first is additive manufacturing transform the fabrication of structurally complicated 3D-dimensional component into stepwise addition of thin materials layers guided by a digital model. Below have a picture that how a component or how a sample made by WAAM, which is a robotic welding, is used to weld layer by layer until a shape is shaping. Next is additive manufacturing enables the fabrication of structurally complex components without using more. So in this method, we can cut our cost to make a mold. Instead, we can use the WAAM so we can get a shape itself. Next is wire additive manufacturing. WAAM adopts an arc as the heat source and the metal wire as the feedstock material. WAAM has depreciation rates with low cost suitable for fabricating large-scale components. So this statement we can verify because NASA also have used the method to fabricate a large component of their engine combustion jet. Lastly, this project investigates the current status of stainless steel WAAM, especially in mechanical characteristics in the sample itself. Okay, for the motivation of my title is additive manufacturing widespread use will improve supply chain effectiveness, shorten time to market, save manufacturing from mass to mass customization, and protect the environment. Next is WAAM has the capacity to fully use the rapid deposition rate of the welding process in order to produce more complicated geometrical components more quickly while preserving the medical quality of the structure. So this is the benefit that I talked about earlier, whereas the WAAM can help the industry to produce a lot of production in short of time. Okay, for the problem statement in my project is design fatigue specimen size and dimension per STM standard, which is ASTM 11. For the tensile test, the machine needs to have a standard specimen to run the test. Next is comparing the trend graph stress strain curve of WAAM from the different source of journal. Lastly is WAAM influence the component's morphology, microstructure, and mechanical characteristics during the WAAM process. Okay, the objective of my project is first to study the underlying of the tensile, hardness, and fatigue life of the stainless steel 3-1CL properties. Second is I need to display the stress strain curve of additive manufactured tensile specimen along the horizontal direction at the top and bottom layer after I done the tensile test on the specimen. Lastly is I want to compare the WAAM mechanical properties and the rod 3-1CL because I want to differentiate or I want to know the stress strain graph between both of the components. Okay, for the literature review for my investigation is I have many journals that I have read before. So I have picked one from the Lily Wei and Jia Sang, which is the correlation between art mode, microstructure, and mechanical properties during wire art additive manufacturing of 3-1CL stainless steel. So this journal is investigate between two modes, speed pass and speed up, which is he want to investigate the mechanical property between two samples from the speed pass and speed up. So first, the journal use seat assist fanning robot, and then when you get the specimen, they cut from the middle layer of manufactured component. So to put in the summary, speed up component features has highest tensile strength and finer solidification structure compared to speed pass. This is the graph, and you can see the highest speed is for the speed arc, which is 550 megapascal. Next, I have a journal from the Jiachen Haiyangwei and Cubao, which is the dynamic mechanical properties of 3-1C stainless steel fabricated by an additive manufacturing process. So first, cold metal transfer process with 31C SS wire with diameter of 1.2 mm compared with commercial rod 31CL. Undergoes tensile test with instrument testing machine at room temperature. So in this journal, the writer investigate between two method, which is CMT process and with the raw, which is rod 31CL. So to put the summary, the writer found that CMT31CL possesses a relative higher ultimate strength but lower ductility compared to rod 31CL. In this graph, we also can see the strength of the CMT31CL is higher but the ductility is very low compared to rod 31CL. So the dynamic yield strength and flow strength for the CMT31CL are higher at small strains compared to rod material. For the expected result in my investigation is in this experiment, I'm only comparing the position of ASTM E8 in the sample at the bottom layer and the top layer only. So next, both horizontal sample which are from the top and the bottom layer taken from the specimen shows the inconsistent deformation of alternating structure and obvious local necking and can be observed in the overlapping area of the sample. So this is a general stress strain graph of my expected result, which is we can see the graph will increase until 350 and down to the near after the fracture occur. That's all from me for this presentation. Anything you can contact me from this email. Thank you.